Hi everyone, and welcome to my talk on visualizing event sequence data for user behavior evaluation in in-vehicle information systems. I will present our approach on how large interaction data that is collected from production line vehicles can be visualized such that UX experts can efficiently and effectively incorporate the data in their design processes. So why is this important at all? The systems we see in modern cars are larger, more complex and probably more distracting than ever, with large touchscreens becoming the main control interface. Last year at AutoUI we presented an interview study in which we found that automotive UX experts require data-driven support, whereas a lot of very valuable and much needed research is carried out using driving simulators or small-scale naturalistic driving studies. Detailed user interaction data and driving data collected from production line vehicles is either not available or not sufficiently analyzed in the OEMs such that it can be an integral part of the UX design process. In the following, we will therefore present the first exploratory approach that consists of different user interaction visualizations and builds upon an existing telematic framework of our research partner. The system architecture consists of three major parts. The in-vehicle logging mechanism is available in all new generation cars of our research partner and enables data collection from the vehicle bus as well as from the HMI interface. The collected data is then transferred over the air to the big data platform where it's further processed and stored. The user behavior evaluation module then accesses the HMI and the CAN data, merges both data sources and computes the visualizations I will present in the following. We process touchscreen event sequence data as well as speed, steering angle and gaze behavior data. In total, we analyzed 27,000 or roughly 28,000 sessions generated by around 500 test vehicles. Our approach aims to benefit a holistic user behavior evaluation by visualizing different levels of abstraction of user-system interaction with the touchscreen interface. We therefore decided to design three different visualizations as each of them answers different questions relevant to the UX experts. The task level view allows UX experts to inspect how users navigate within the system, what the main interaction flows are, and how they relate to each other. The flow level view provides a quantitative comparison of different flows based on a chosen metric. And finally, the sequence level view enables UX experts to analyze certain sequences regarding the interrelation between touch interactions, glance behavior, and driving parameters. To better understand the visualizations I will introduce in the following, we will use the route guidance task as an example. We will now show one specific flow on how this task can be completed. So this is the first screen, and when tapping on the Navigate To button, a new screen is presented. We can now start typing, and if we just choose the first element out of the list of suggested destinations, a new screen is presented. The last action is now to check the destination and press the Start Navigation button. Looking at this example, we can already see that there are multiple different possibilities on how the route guidance can be started. We decided to choose to go over the keyboard typing, but we can also choose the tab to choose one of the previous destinations or favorite destinations. To visualize these different opportunities and to create an easy to grasp overview about how drivers navigate within the system, we introduce the so-called task level view. We remember that for this example we defined the route guidance task to consist of all sequences that start with this Navigate To button and end with a Start Navigation button. The task level view is an aggregated visualization of all sequences that belong to a specific task. The flows are visualized in form of an adapted Sankey diagram with color-coded links to visualize the temporal dependency between different steps. The main components are nodes and links. Each node represents an event at a certain step in a task, and each link connects two nodes representing a transition between two events. So this is the task level view for the navigation task. We can already see that we have a lot of different flows that in the end perform the same task. So we will just take a look at the flow we already walked through in the screenshots. So all flows start, of course, as defined with the Navigate To button. And we see that we have roughly 1,000 sessions here. And after tapping on the Navigate To button, it's roughly 62% of all people that start typing on the keyboard. We can see that with hovering over this transition from the Navigate To button to the on-screen keyboard tab. And this basically represents all taps that are done on the keyboard. After typing on the keyboard, which takes all the users on average 11 seconds, which is displayed here when we hover over this transition, users choose something out of a list, and afterwards they need on average 3.5 seconds to check that the right destination was chosen and to start the route guidance with this Start Navigate To. And we can already see the different flows, how they are distributed, and what is the preferred way of users on how to start the navigation. For example, 62% of the users decide to enter the destination via typing on the keyboard, whereas 28% decide to choose a destination out of the previous destinations list, and 7.2% decide to choose a destination out of their favorites. Having now experienced the task level view, we continue with the flow level view. Whereas the task level view provides an overview of the flows and how they are distributed, a comparison between flows with regard to a certain metric is not sufficiently visualized. We therefore created the flow level views that shows the distribution of a certain metric of all sequences that belong to the same flow. The different flows that belong to the same task are shown next to each other to facilitate the comparison between them. We decided to use violin plots as an enhanced form of box plots since they make it easier to assess the distribution of data points, in this case the individual sequences. If we now take a look at the example view where we compare the different flows with regard to their time on task, the blue violin represents the flow that we walked through in the example when users type on the keyboard. The orange flow represents users who choose the previous destination option, and the green violin represents the favorites option, and we can already see that it's way faster to either choose the favorites or previous destination option, which is quite obvious, but it's also 1.8 seconds faster to choose the destination out of the favorites compared to choosing it out of the previous destinations. Whereas the task level view and the flow level view both show aggregated statistics to infer general trends regarding user behavior, the sequence level view, in contrast, aims to generate insights on the level of individual interactions and individual sequences. In addition to the interaction sequences and the glance behavior, also driving behavior is visualized for those specific situations. The example shows 3 different situations, and each visualization consists of 2 main parts. The upper part is an overlay of the touchscreen interactions, the blue dots, and the driver's glances towards the center display, the orange lines. Each dot represents one interaction, and each line indicates the duration of a glance towards the display. The lower visualization, consisting of 2 graphs, represents the driving-related data, the vehicle speed in green and the steering wheel angle in red. Now we will take a look at one specific example in more detail. In this example we see a specific sequence for the route guidance tasks, and we can clearly see that the head unit glances starts here at 0, and the first glance takes around 2.9 seconds, which is already pretty long. And after roughly 2.5 seconds, the Navigate To button was pressed. Then the driver looks away from the head unit, and then a long glance again starts. The driver starts typing on the keyboard, checking the road again, typing on the screenboard, then a long glance appears. And then the user chooses, drags on the list, and then chooses something out of the list, and finally starts the navigation. As one can see, those are pretty long glances. The speed decreases during the time, and we can also see some steering wheel reversals. Since this is a first explorative approach, we were interested in how participants interact with the visualizations, what needs to be adjusted and what they think is missing. We therefore recruited 4 UX experts from our research partner, and after an initial walkthrough we asked them to perform 7 different tasks and to answer a survey afterwards. The general feedback was very positive, and the participants expressed that they see multiple use cases for such visualizations in their design process. The task level view was considered most helpful and served as a kind of anchor point during the different tasks. The flow level view has proven to be very important for comparing individual flows quickly at a single glance. However, 2 participants really struggled to interpret the violin plots. The sequence level view was considered very important, and participants valued the a possibility to show some example sequences, arguing that it benefits their overall understanding of how people interact with this system. That's all, and I'm now happy to answer your questions.